Alright, this video is going to walk you through the thinking behind knowing how to decide when an equation is going to be always true, sometimes true, and never true. The always true is referring to when you have infinite solutions. The other one that you're thinking about is when you've had a no solutions. But sometimes the infinite solutions are not always infinite. There are some restrictions, and that's when we're going to say sometimes. So let's think about what we have over here in this first equation where I have x equals x. If you ever get that in an equation and you solve for x, you're going to end up getting a true statement. Yes, no matter what number I put in for x over here, like the number 5, it's going to equal 5 over here, and 5 equals 5, so 5 would be considered a solution. I could also put in 10. 10 would equal 10, and that would be a solution. But think about it. There's no, every number you think of that you put in for x here is going to work out as a true statement. This is an example of what infinite solutions looks like. And you would say that this equation is always true for x. I could get a little bit more complicated, but not really. I could take this expression. We know the distributive property to be true, that if you take this 2 and multiply it into x, you'll get 2x plus 6. And if 2x plus 6 equals 2x plus 6, you would say, hey, well, that's an equation that's going to have infinite solutions too. No matter what you pick for this 2x plus 6, you're going to get the same answer on both sides. For example, if I were to choose to put a 5 in both of these x positions right here, well, if I do that, then I'd have 5 plus 3 times 2, that gives you 16, and 2 times 5 plus 6 gives you 16 also. It doesn't matter. I could pick another number, like 8. Let's put 8 in both those spots. You'll realize that when I put 8 in both of those spots, I still get 22 and 22. So no matter what I put in for these x's that you see right here, I'm going to always get a true statement. So that's going to be infinite solutions example also. So if I saw this equation right here, I would say always, or something like that as well. Now we can also have some problems like this, where I have 2x plus 5 equals 2x plus 6. And if I were to try to solve and get x together, I would subtract 2x to both sides, and then I would just be left with 5x, or 5 equals 6. Well, that's a false statement, and that's in the past we said no solution. So you would say in this equation here that this equation is never going to have a solution. Okay, never going to have a solution. I could also have a simple equation like this that says 0x plus 1 equals 2. No matter what you put in for x right here, you're going to always have 1 equals 2, and that is not true. There is never going to be a number you can put in for x in this example either that will give us a true statement, because 1 will always equal 2. So here are two examples of what never looks like. Now you're also going to find in your homework today some questions like this. We know how to simplify an expression like this because we have an x plus 2 on the top and we have an x plus 2 on the bottom, and we can cross those out, leaving you with just x plus 2 equals x plus 2, and yes, you would say infinite solution. But now what makes it sometimes is we have the rule that says you cannot divide by 0. So if you ever have an original question like this that has x in the denominator of something, you need to start thinking critically about what does the one or multiple values of x that it cannot equal to that might create a 0 in the denominator. So in this case right here, I would not want to have a negative 2 here, because negative 2 plus 2 gives you 0, and you cannot divide by 0, so therefore that one individual number is the one that will ruin it from you being able to say always. So that's why we say sometimes. So sometimes is then going to be x not equal to 2. Now as you look over at this example over here, you're going to see that it says x squared plus or minus x minus 90. If you factor this, you're going to end up getting x minus 10 times x plus 9. And then if I have x minus 10 times x plus 9, the x minus 10s will cross out, leaving you with just x plus 9 equals x plus 9. And again, as you factor this out and things reduce, we have an infinite solution situation. However, we cannot have x equals 10. So as you look at the choices that are on this list here, I would say that yes, this is going to be sometimes true, only because I have an x in the denominator. And then I got to say, what is the criteria for x that's going to ruin it or not work mathematically? X cannot equal 10. So you're going to say then on this list right here, you're going to say x cannot equal 10. And that would be this choice right here. Then, by you saying x can't equal 10, that implies that every other number will work. As you submit that, hopefully, you get them green for both choices. That is how you do this question, and that's the thinking behind it. Sometimes you have never, sometimes you have always, but then when you have x in the denominator of a fraction, think critically about what makes 0, and you'll have to rule that out of your total infinite solutions and say sometimes. Good luck, and hopefully this video helps.